Okay, this is some documentation of what I'm working with, a pulse width modulator, and I'm working with resonant energy, free energy, resonance, and this is my circuit set up with a toroid TV yoke core, and I've got a microwave oven lamp, I've got a car dash light. They're about 10 watts, this is about 30 watts. And I had some fluorescent lamps connected to it already. So this is just looking at what I have set up here right now. I've had it all working fine. As you look over here now, you'll see my 800 watts of Kapanadze generator, and that's working real good now too. You can see the spark gap over there just barely kicking in. Let's see if I can get close to it. I don't know if you can make it out on a cam, but it's a microwave oven transformer with a capacitor and the diode. And this is the Kapanadze coil I got. Definitely it does not work without the grounds. Definitely will not run without grounds. The brightest lamp here is the 100 watt bulb. I got it in there just to make some light in here, but the other lamps, they don't look as bright, but they are lit, and it takes a lot to light them guys. 200 watts. This is my cabin and shop and lab at the same time in my little room, and I do all my work circuitry here right now indoors because outside it's a mess. It's a blizzard. So today is the 3rd day of January, Sunday, 2014. And it's about 11:40. Well, now it's 12:40 a.m. in the morning, and I've been up all night. And I'm trying to get this thing going here. I'll turn it on. I'm going to plug this in here. Bingo. See what I got going. Oh, just dropped it. Trying to do it before that microwave oven transformer gets too hot, but this is the I gotta be left-handed with it. This here is the microwave oven transformer lamp. This is the lamp for dashboard behind it. These are LEDs with little coils on them, and this is a slip ring. It slips. It's a current transformer. It slips along the cable. It's like a current transformer. And I put little ones inside there too, and I just lost that one. See if I can get them out, but you put him on the side here and he lights up. See, you lay him on the side next to the coils and he lights up, or you lay him sideways that way. So I got it running at, there's the amperage, 0.01 amps. You get close up of that thing, 0.01 amps, because when I unplug it, you get this, 0. When I turn it on, you get this, 0.01. That is right in line with the incoming battery, and there's a lot of battery down there. I got a solar cell charged battery bank here. I'm flickering with my transformer. Let's see if I can adjust it with the, play around with the dimmer light on there, but it makes it plenty bright in here. I noticed, almost like daytime. And I like this camera because it's got a lot of stuff, neat stuff on it. It's a helmet cam, and it's a JVC HD cam. And I thought I'd get myself in here, but the only problem with this thing is it has a side-mounted LCD screen. It's hard to see what I'm pointing at, but I like the way it handles. It doesn't make everything jittery. But this is the setup. It's been running like this for 2-3 hours now. And the heat sink for the transistor is just a little warm room temperature. And it's only run on 12 volts at 0.01 milliamps. The scope display, they're all spikes. 14 volts right across here, I read on there. I touched one of the probes, the probe at 5 volts per division at this side, and it was positive amplitude, but on the other side it was negative amplitude. So that was very, very interesting. I did not know or ever seen anything like that. But I think it's AC and DC running at the same time. This resonant energy stuff. It's like it looks like hydrogen gas. It's orange. And the hotter it gets, the brighter orange it gets. So anyway, yeah, there it is. Look at how bright that light is. That's on a toroid. It's really sucking up the current there. So I thought I wrote down everything on my chart here. I made a list of what is a resonant circuit, and showed the oscilloscope displays. The potentiometers are real finely adjusted. There's a whole bunch of leads coming off of this toroid core that I wound. There's about 6 different wires on it, and that was to test how much you can get out of the thing. All of them put out some juice too. Every one of them. See, I touched that one and it kills that. I touched this one here. Sparks out a little bit. Let's see how much spark I can get. You can barely see the spark, but there's a spark, and some of them kill it, some of them help it. Depends on what you're touching here. See? But it's a very interesting circuit. I believe it's in resonance right now. Because when I turn my pots and get them out of resonance, I get 2 amps on my multimeter. And it starts going up when it's out of resonance. So 14 volts, 0.01 amps, resonant circuit, AC and DC waveforms at the same time. That's it. I'm going to call it quits for now. And I'm going to pull the plug and turn off my Kapanadze, because those lamps too, you see, they're all lit. They're pretty warm to the touch. This guy's real hot. And the transformer I know is getting hot, starts stinking. But I notice the dial, once you turn it up, you turn it on, it kicks on, and then you turn it down. So that's interesting. So that'll end my little video journal report for today, January 3rd or 4th, Sunday, 2014 now. That's it.